Hello everyone. Welcome to my session, Unveiling the Power of Intune. So my name is Yue Chudo and I work for SecureWorks and I provide red teaming services for mainly enterprises in Japan. So today's presentation is mainly about Microsoft Intune, but first let me talk about what Microsoft Intune is and what is it. So Intune is, I think you might know, but endpoint management solution, and it is very useful for managing devices and enterprise. And it has a lot of features such as configuration management and application deployment and so on. And if you look at enterprise device management these days, we have seen a lot of companies using Active Directory and group policy and also SCCM, configuration manager. However, more and more companies have started using Entra ID and Entra ID's Conditional Access and also Microsoft Intune. So I think Microsoft Intune has a lot of features, and I think it is becoming the main component of the endpoint management. So I thought Intune might be a great target for my research. This is why I started researching Intune and tried to understand how Intune is working internally and how attackers can abuse it. So today, I'd like to share some of the findings from my research, and also I'd like to share some of the findings from our red team engagements. First, I'd like to take a look at the overview of the mechanism of Microsoft Intune. Then I will talk about some attack techniques abusing Intune. And also, I'd like to introduce a new tool with demo. Finally, takeaways. So let's dive into the internal working of Microsoft Intune. Here, I'd like to mainly look at two components about Microsoft Intune. First, I'd like to talk about device enrollment, which means how devices enroll to Intune. And then I'd like to look at device management, which means how Intune manages the device after the device enrollment. So let's take a look at the device enrollment first. So I'm gonna talk about the steps of the device enrollment. And if you want to enroll your device, first you need to install the Intune Company Portal app in your smartphone. And once you install your app and open it, you need to log into Entra ID. I think you might have seen this before, but you type your email and password into this app like this. And once the app receives the credentials, the app sends login request to Entra ID. And this is the example of the login request. And what we want to look at here is that the client, it has the client ID of Intune Company Portal app, which means that this login is made by the Intune application. And after the successful login, Intune application receives access token from Entra ID. And with the acquired token, the app sends discovery request to know which server to talk with for device enrollment. And here is the example of the request to discover the enrollment endpoint. Then it receives JSON responses like this, and it has the URL for the device enrollment service of Intune. And this URL is used for enrolling device to Intune later. But before enrolling device to Intune, the device needs to be registered to Entra ID by talking to the Entra ID's device registration service. So once device is registered to Entra ID, you can see the device like this in the Azure portal. However, the device is not registered to Intune yet. And to enroll the device to Intune, the device has to send an Intune's device certificate to the enrollment service of Intune. And this is the example of the request for enrolling device to Intune by Android device. And the request has the access token received from Entra ID, and also the request has signing request of the Intune's device certificate. For this enrollment request, RSA key pair is generated and enrolled to Intune for the device authentication. Then Intune application receives signed device certificate that can be used to authenticate to Intune. Also, it gets DM server URL, which is the Intune's management server URL in this response. After the enrollment request, device is finally enrolled to Intune. So after the device enrollment process, the device object is created in Entra ID and also in Microsoft Intune. And both objects are linked via device ID extracted from the access token in the certificate enrollment request. So if device information is changed in Intune, then it is synced to Entra ID, since both objects are linked via device ID. Now, let's take a look at how Intune manages its device. So once the device is enrolled to Intune, the device communicates to the Intune management server through OMA DM protocol. And during the protocol, the management server can identify device through the enrolled certificate. As for Windows, you might have seen this sync button. And if you press this button, you can start the communication manually. And this is also called check-in. And during the communication, management server sends a request called syncML request. This request defines what device should do, like sending OS version information to Intune or configuring registry settings. And once this syncML request is received, then the device sends back syncML response, which contains the result of the request. And in the syncML payload, the DM protocol commands are defined to issue some orders to the device. And there are several commands defined in the protocol. For example, get command is to query some data from the device, and exec command can be used to run some executable in the device. And when ordering the command, the URI is also specified to indicate which settings needs to be configured. And this URI is called OMA URI. So through this protocol, the device and Intune's management server communicates and exchange information. And this is basically how Intune manages device. So we briefly looked at the overview of how Intune handles a device. So let's look into how attackers can abuse Intune. So for this presentation, I'd like to talk about totally 4 attack techniques found through the research. And 2 of them are related to the enrollment process of Intune, and the other 2 are related to the management process. Let's look at the first one, which is about bypassing conditional access. So you might already know, but access to the cloud can be controlled by the Entra ID conditional access. And one of the common policy configured in many enterprises I see is require compliant device. And the policy can allow access from device that is marked as compliant, and the policy can block access from untrusted device. But how is this compliance status decided? So in Microsoft Intune, IT admins can define compliance policies such as disk encryption or password requirements and so on. Then Intune evaluates each device information, and Intune will mark compliant based on the compliance policy. So if the device is not marked as compliant, then the access from the device is blocked by the conditional access policy. And this is the example of the token request by the tool called RoadTX. And as you can see, it is blocked by the policy. So as you can see, the access to resources like Microsoft Graph can be blocked from the untrusted device like this. However, getting back to the device enrollment process, the Intune application first needs to log in and make an API call to the Microsoft Graph, right? So if the conditional access policy requires compliant device, then this might break the enrollment process because the device is not marked as compliant before the device enrollment. So I checked to see if the access can be blocked by the policy. And I found out that actually the access is not blocked by the policy. And I specified Intune apps client ID in the login option to make the login request looks like it is from Intune application. And by doing this, we can see that we can acquire the access token for Microsoft Graph. And this means by using the Intune application, the access is not blocked, even when the access is from non-compliant device. And we can acquire a token to access Microsoft Graph and make an API request to Microsoft Graph to steal some data in the cloud. However, the token acquired through this approach has limited scope, as you can see in the decoded access token, and it can only query some of the data in the cloud with this acquired access token. However, this approach also allows us to acquire access token for Azure AD Graph, which is the former version of Microsoft Graph. And as you can see, the scope of the access token here is user impersonation, which means that we can make a Graph API request on behalf of the signed-in user, and this allows us to access more data comparing with the Microsoft Graph token. By using the Azure AD Graph token, we can steal data on the cloud-like employees, all of the employees' information or all of the device information from the untrusted device by using load recon, which is one of the enumeration tools. Using that tool, you could even dump all the configurations from the conditional access policy. So from this, we know that we can bypass the required compliant policy through impersonating Intune application. Then what happens if required Microsoft Entra hybrid joint device policy is also enabled with the required compliant device policy? In this policy, you would imagine that with these requirements, you need Active Directory and also Entra ID joint device that is marked as compliant by Intune to access data on the cloud based on this policy. And when this policy is enabled, the user login request is blocked, and it says that you need a domain joint device. However, if the request is from Intune application, then the access is granted, and you can acquire the access token to steal data on the cloud. So we can acquire access token for Microsoft Graph and also Azure AD Graph by using the Microsoft Intune Company Portal Client ID, and you can bypass the device restriction policies in Conditional Access. So in our red team engagement, we have abused this many times to extract information out of Entra ID by using the stolen credentials without any access to the target corporate device. I submitted this issue to Microsoft, and of course they said this is by design because they don't want to break the device enrollment process. So thanks to the Intune device enrollment process, we can bypass the conditional access policy. And also here, they recommended to enable other policy like MFA. So okay, I enable the MFA, and if MFA is required, then even with the Intune Company Portal app, the access is blocked only with just email and password. This could entirely block the access even when credential is leaked to attackers, right? However, there is a case where this MFA also can be bypassed. So we have seen many enterprises exclude Microsoft Intune in target resources from the conditional access policy like MFA because they don't want to force employees to do MFA when enrolling their device. With this exclusion, it seems that access to only Microsoft Intune can be excluded from the policy. That's what I thought. Of course, access to Azure AD Graph only with just email and password is blocked since as we have seen, the Azure AD Graph is not excluded from the MFA requirement policy. However, with the Intune application ID, token is acquired without MFA. So what this means is that attackers can access Graph API using the Intune application ID without MFA when Microsoft Intune is excluded in target resources. We have seen these configurations in many enterprises, and in our red team engagements, this helped us to access Graph API as global administrator user without MFA, and we could entirely compromise its tenant. I submitted this issue to Microsoft, and Of course, this is also by design. And what they said is that when you exclude some resource in conditional access policy, then dependencies are also excluded at the same time. So when you exclude Microsoft Intune, then access into Graph API is also excluded from the policy internally. So this is why MFA could be bypassed, as we have seen before. So for this attack, what I recommend is the device restriction policy could be bypassed, so MFA enforcement policy should also be added. However, MFA enforcement policy can also be bypassed when some exclusion is added, so try not to add any exclusion to policies for high-privileged users. Or you could also consider applying application filters to target Azure AD graph with the same control. So let's take a look at another attack related to enrollment process, which is to delete device objects through enrollment process. Looking at the certificate enrollment request in each platform, I found that there are differences in the format and the parameters included in the enrollment request. And in the previous example, we have seen Android's XML-based requests, but on the other hand, Linux sends JSON-based requests with different parameters, and Apple device sends XML with PKCS7 sign. And looking into Android's request, I noticed that it doesn't need access token without device ID. It doesn't need access token containing device ID. Also, device ID can be specified in the AAD ID parameter. So what I thought was that what happens when other device ID is specified in the enrollment request. So the scenario is that there is already other user's device object registered in the Entra ID and also Intune, and attacker tried to enroll device to Intune with the existing device ID. And by sending the enrollment request with the other user's device ID, what happens is that the existing device object is deleted from the Intune service. And when the object is deleted from the Intune, IT admin cannot access and manage the device anymore like this. If I have access to the target's tenant, then I can query all the users' device IDs. So through this vulnerability, I could destroy all the devices in the target's Intune. And I submitted this issue to Microsoft, and they said that this is not by design, and it is already patched this year. So with this vulnerability, attackers can delete device object in Microsoft Intune by abusing Android cert enrollment endpoint. And it is already patched, but what I want to point out here is that Intune supports multi-platform, and they are different from each other, and too complicated, so there should be more abuse by using the differences of multi-platform. So let's talk about attack technique in the device management process. The first one is about establishing a foothold through OMA DM protocol. So Microsoft Intune can configure device setting. By creating a profile, it can manage various device configuration like network settings. And a lot of enterprises utilize this function for setting up corporate device. And looking into the Intune application, I found that the device configuration is delivered through the communication between device and Intune management server. And if you look at the DM sync message, the add command contains the device configuration. And this example shows the address of the internal VPN. And also the Wi-Fi settings like SSID and password are also delivered through the DM sync message. So these configurations are great resource for attackers to break into internal network of the target enterprise. So based on the research, I thought that if we can steal victim's credential, or if we can steal token through a device called phishing, and if we can replicate all the steps Intune app handles, then we can steal the configuration data, such as VPN and Wi-Fi. So that's what I did. And by emulating Intune application, successfully I could steal the network information like VPN and also Wi-Fi credential. Also through the research, I found installer files for line of business applications are downloaded during the session. And we have seen many IT admins deliver installer files for VPN client like Zscaler or Cisco. So replicating Intune application help attackers to access the internet network and attacking the resources there. However, I figured out that we could steal more. So I think you might have heard of autopilot. And this helps employees to set up the device by themselves and register the device to Entra ID and Intune. And this autopilot also allows employees to automatically join the device to Active Directory. This is called hybrid autopilot. And the process is that first you enroll your device to Intune, and then Intune will send the device information to the system called Intune connector. And Intune connector creates a computer account and receives an offline domain join probe from Active Directory. And it sends back the domain join probe to Intune, and Intune sends domain join probe to the device. So this domain join probe has a computer account credential. So by using the computer account credential, that device can be a domain join device. And looking at the communication between autopilot device and the management server, I found that the device sends the hardware hash information through the DM sync message. And once the device sends the hardware hash, Intune enrolls the device as autopilot device and sends back the offline domain join probe, as you can see here in the response. So by replicating this step as well, I found out that we can impersonate autopilot device and leak Active Directory's account credential. So in summary, we can enroll a fake device to Intune and communicate with the management server through OMA DM protocol. Then we can leak the device configurations related to internet network like VPN or Wi-Fi. And also, we can steal the domain computer credential depending on how the environment is configured. So this approach is very useful for attackers to establish an initial foothold leveraging Intune. What I recommend here is that you need to block log device enrollment through device filtering and enrollment restriction settings in Entra ID. Additionally, this might be bypassed, so you also want to block credential phishing and device code phishing through conditional access policies. Now, let me talk about the last one, which is about SideCar. First, let's take a look at application management. As for Windows, we have seen installer files for line of business applications are delivered via OMA DM session. On the other hand, PowerShell scripts and Win32 apps, such as exe and batch files, are downloaded through what is called Intune Management Extension, also known as SideCar. And SideCar is installed through OMA DM session after enroll to Intune. And once SideCar is installed to the system, this allows IT admins to push and manage Win32 applications and PowerShell scripts. And Win32 apps like exe files are packed into a file called Intune Win file. When delivered, and SideCar unpack the Intune Win file and install them into the system. So as a red teamer, these in-house applications are always great targets because they usually contain some credential. So I decided to research on this as well. So let's take a look at the app deployment through SideCar. During the OMA DM session, management server asks device to install SideCar. And when installation is ordered, DM client downloads SideCar from the CDN server and install it into the system. Then SideCar starts communicating with the SideCar gateway service. And if there are any apps to be installed, then this service asks SideCar to install the apps. Then SideCar downloads encrypted Intune Win file and decrypted it by the Intune's device certificate and install it to the system. As for the communication between SideCar and gateway service, the JSON data is exchanged for communication. And the SideCar is authenticated to the gateway service via the enrolled Intune's device certificate. And the JSON data contains the gateway API to query data from the cloud, from the gateway service. And this is the example of the request from the SideCar, and it specifies the gateway API depending on what kind of information SideCar wants. For example, SideCar can download partial scripts through policy request API. The following is a response of the policy request API, and it contains partial scripts in the JSON data, as you can see below. And as for another API called getContentInfo, this API returns decrypt info that contains Intune WIN file URL for download and also AES key for decryption. And once SideCar receives the required information, the SideCar downloads the Intune WIN file and decrypts it to install them into the system. By replicating SideCar downloading process, I was able to download and decrypt the Win32 apps like this. So attackers can impersonate the SideCar, and they can steal your partial scripts or Win32 apps delivered from Intune. And those custom apps are always great target for attackers, since they sometimes contain juicy information such as local administrator passwords or domain even administrator passwords. So these might be stolen from this attack. So this might be sometimes hard to implement, but I'd like you not to deliver apps that contain secrets. I have seen many enterprises deliver applications with secrets. And in our engagements, we have seen delivering apps only to a particular dynamic device group, but this could be bypassed by entirely faking Intune protocol. For example, I have seen delivering even service principal certificate to a device whose name starts with admin, and it was bypassed. So you want to avoid delivering apps with credentials if possible. So now let me introduce a new tool with a demo. So I implement a tool called Pytune that could execute the attack techniques I talked about in this presentation. And this tool can enroll a fake device with multi-platform and talk to Intune like it is real. Let me show you how it works. So this is the attacker's machine, and I have the Pytune script right here. And I will start the attack with device called phishing by executing .tx. Here, I will specify the device registration service as target resource. And once you execute it, you get the code to send to the victim. Now here is the victim's machine, and employee 01 account is logged into the system. And through the phishing, the victim goes to the device code authentication page like this and type the code sent by the attacker. And the victim follows the authentication flow. And as you can see, the authentication is done. Then once the authentication is done, the attacker receives the access token and also refresh token. And let me save the token in the variables. And first, with the token, in this attack, we will register the fake device to Entra ID by executing Entra join command in Pytune. And fake device is named as Windows Pytune, and we will provide access token. And once you execute it, as you can see, the fake device is enrolled to Entra ID. And also, if it is successful, then the Pytune will receive the device certificate for Entra ID. But the fake device is not enrolled to Intune yet, so we will execute the enroll Intune command to enroll our fake device to Intune. And we will provide OS information and also the device name. And we will provide a refresh token acquired the device code phishing. And we will provide the Entra ID's device certificate. And once you execute it, Pytune will talk to Intune and enroll a device to Intune like this. And once the device is enrolled to Intune, then Pytune will receive the Intune device certificate. So since we enrolled our fake device to Intune, we will start the check-in with the device certificate through check-in command in Pytune. We will provide the Intune device certificate here. And here we will provide the hardware hash to enroll our fake device as autopilot device. And once you execute it, then Pytune will start the communication with the management server. So you can see the Pytune will correct the configuration profiles. And here you can see the VPN configurations are delivered. Of course, this is just the example, but you can see some of the internal VPN configurations. And also you can see Wi-Fi settings like this. And you can see the Wi-Fi password and SSID like this. So now let's do the check-in again. So it's done, and this time we can see that the Pytune has successfully downloaded the MSR file from Intune. You can see the MSR file in the folder like this. This is just an example of the MSR file, but we have seen a lot of enterprises deliver installer files for VPN client. So these might be very useful for accessing to the internet network, right? And as you can see here, we successfully acquired the domain chain proof, and we can acquire the computer account name and also the computer password. So with this information, we can start attacking the internet network and Active Directory. So finally, in the demo, let's download the Win32 applications and also PowerShell scripts. We can do this through the download apps commands in Pytune. And once you execute it, the Pytune will download the PowerShell script if there is any. And this is just the example, but sometimes we see the local administrator password like this. And also, Pytune will download the Win32 applications, and we see several Intune Win file delivered to the fake device. So you can see the downloaded Intune Win file, and Intune Win file is just a zip file. So you can see the original exe file is downloaded. And also, we have also another MSI Intune Win file, and we can see the custom batch files are downloaded like this. So that is all for the demo. Let's move on to the takeaways. So Microsoft Intune offers lots of useful features, but at the same time, we have seen many opportunities for attackers. And by leveraging Intune, attackers could break into your internet network and cloud resources. So I recommend to review and harden configurations such as Conditional Access or Intune's device settings so that attacks become harder and harder. So this is all for my presentation. And if you have any questions, I'll be around here, so you can talk to me after the session, or you can send some DMs to Twitter or LinkedIn. So that's all. Thank you very much for listening.